thanks very much for joining us today. So this is one of our New Vic STEM talks. We're really pleased to have Jev Gamper with us today to talk to us about, here he is, here's Jev, here to talk to us about his career, how he's like, where he started, where he's been, where he's going, what he's interested in AI and machine learning, and some tips for you guys on like maybe how you can sort of negotiate the world of, you know, the STEM world, the research world. So yeah, like I said again, thanks very much, Jev, for joining us. Over to you.
Yeah, thank you for having me. Really excited to be here. Excellent opportunity for me as well as for everyone else who joined here. So, and there are my details on every slide. So if there are any questions anyone has, please reach out to me. I'll happy to answer any questions or help in whatever way possible. Always open to any sort of communication. So yeah, I'll get started with a few slides that I've prepared. Kind of the title is Careers in STEM and specifically AI and machine learning. And the background that I've chosen here are different papers that researchers within AI and machine learning publish. So you can see anything on the background from topics of software engineering to deep learning to et cetera, et cetera. And what I wanted to make a point here that while STEM and research in particular is a lot about oh, what is AI? Someone is asking. AI is artificial intelligence. Good question. I should have clarified that right from the start. Thank you.
As well, yeah, and that's an important thing as well, is if you have any questions as we're going through, absolutely put them up. Absolutely, you can ask any questions, and we can either answer them at the end or like as we're going, whatever you like. Yeah. Yeah.
Excellent. Yeah, so a lot of research in STEM and AI and ML is about publishing papers of what is artificial intelligence. Well, there are many definitions of artificial intelligence, but the simplest one could be that you have a computer algorithm that classifies pictures of cats and dogs and does it really well. So that could be a type of artificial intelligence, that's so-called narrow artificial intelligence. This is also sometimes referred to as machine learning because these algorithms learn to classify cats and dogs because you serve them loads of images and you give them examples. This is a cat, this is a dog, and they slowly pick up from these images that what classified as cat, what is classified as a dog. And so like I was saying, a lot of that is about publishing papers, but before we talk further about it, let's first understand what is publishing papers and what is research. What is research? And here are 3 examples of papers that have been published at different conferences with my notes on it. Often as a researcher, I will go through these papers, make different notes, underline different things, trying to understand what is the current state of the art in the field. And the research itself is about asking new questions that no one has asked before, and then trying to find answer to these original questions that you've came up with. And it could be anything in healthcare, it can be some theory, or it could be something like climate or earth sciences. So here are 3 examples. The paper on the left was presented at AI for Social Good workshop at a conference in Canada in 2019. And they asked, for example, a question, what could and should be automated in healthcare? And it seems like a quite simple question, but actually you can derive science and mathematics modeling to determine what's optimal to automate, what is not optimal to automate. And then they show that in their paper. Or in paper in the middle, they study the models called generative adversarial networks, or abbreviated as GANs. And this is also a very interesting piece of theory. Or they study applications of machine learning to climate science. And specifically, can we use machine learning to model how our climate or our Earth's atmosphere evolves as the time goes? So there are all sorts of different applications that you can do with AI and machine learning specifically. So some of the things that I had an opportunity to do are asking questions, I don't know, what is a Rife machine? I see a question. David, do you know what is a Rife machine?
I'm sure what a Rife machine actually is.
I don't know. I don't know. Maybe someone
I
could
don't know.
clarify that in the
No,
question.
what is a Rife machine? We don't know.
Yeah, I don't know what is a Rife machine. Sorry. So I'll move slowly forward. So some of the machine that produces Rife frequencies.
I need to look that up.
Yeah, I will have to look that up myself. I'm learning something new every day. But thank you for the question. Anyway, I'll be moving slowly forward. So some of the questions that I got to ask in my research career was related to detecting planets in other solar systems in our galaxy. Specifically, I worked with detecting exoplanets. So in this case, I have a GIF in front of you. This is a sun with a small planet passing in front of it. I don't know if you can see the black dot moving on the screen, that is a tiny planet passing in front of the sun. Now the question we had, can we use some methods to look onto the stars in our galaxy and quantify how many planets are out there? What is the frequency of other Earth-like planets appearing in the space? And that's precisely the question that I got to work on as master's students as part of mathematics, applied mathematics degree at Warwick University. And we were applying machine learning to what's called Kepler satellite. Kepler satellite is a satellite in the space that looks at a few millions of stars. And what it's looking at is it's recording its brightness of the star over time. So you can see here, we have time axis and we have light axis. And as the planets pass in front of the star, we see a dip in the brightness of the star. And we can record all of that data and then apply machine learning to that data to then classify which dip corresponds to a planet and which dip does not correspond to a planet, but might be produced by some noise in the space. And this work that I've done during my master's turned out to be a paper publication in the Royal Astronomy Journal, which was very exciting. And we detected 50 new planets in the space. And that was really cool. Oh, what is a work-life balance? That's a very good question. So that depends on if you're in industry or if you're in academia. And if you're in academia, it depends if you're a master's student or if you're a PhD student. And also, when you're a master's student, you usually have a very well-defined program where you have 1 year of studying different courses, can be quite intense. And then your summer project would be research. So this was my summer project that ended up being a paper. And then after the master's, when I went into PhD is a bit more intense. But again, that depends on how well of a structure your PhD supervisor gives to you while you work, and how good does your supervisor supervise you to create a good work-life balance for you. So hopefully that answers the question. And moving on, from working on exoplanets, I started working on medical imaging and machine learning as part of my PhD, which I will talk about later on. But besides publishing papers in science and doing research, a lot of it is also about the community. So STEM is far more than papers. You also go to events that form communities in STEM, or academic communities or research communities. And one example of that is Neural Information Processing Systems Conference. So this is me attending a conference on artificial intelligence. It's one of the biggest artificial intelligence conferences in the world, extremely popular, extremely hard to get into. But they had 12,000 participants in 2019 in this conference. And it's researchers gathered from all across the world presenting their papers as posters. You can see in the image on the bottom left, all of the people, all of the researchers gathered around the poster from Google Brain Research Group, where they're presenting their findings about specific topic or the question that they were looking at. And then on the upper left image, you have a big hall where researchers are listening to some of the presentations by other researchers. Then the picture on the top middle, these are pictures of different sponsors of this conference. So you can see that a lot of industry is actually extremely interested in what's going on at these conferences, because this is essentially what drives the products developed by these industries. So if you think Google, if you think Amazon, Microsoft, or self-driving cars or Facebook, any of those companies, they actually actively attend and participate in these conferences too, and in fact recruit at these conferences. So I had crazy experience at this conference when I got invited to a party hosted by Apple, by Google, and by I believe Microsoft, because they try to invite researchers to these parties and that way attract them to their company. And then the picture at the bottom middle, this is me and Andrew Ang, who is the head of, who was one of the founding members of Google Brain's kind of division within Google to work on AI. And he is also famous for his Coursera course on machine learning. So that was really cool to have a picture with him, because his Coursera course was one of the first materials I've used to learn machine learning, because it's openly available course for anyone to start. And it's also academic conferences in STEM is an opportunity to travel. So I included a picture here where I got a chance to hike up the mountain in Vancouver in Canada and just see the nature out there in Canada, which was really cool. So yeah, it's much more than papers. It's also about build communities that are around these topics. And then when I was doing my master's and PhD, it's also a community that is formed. So for example, picture on the left top, I got to go to a conference in Italy, in Sicily, and meet different researchers there. Or I got to learn climbing by meeting other researchers, and they told me climbing is awesome, so I started climbing with them. I met all sorts of people while doing my research and got a chance to work with pathology doctors in Coventry University Hospital. So this is a picture at the bottom left, where I work with the pathologist to develop algorithms to classify different diseases on the pathology slides. And also helped organizing different conferences for medical doctors and machine learning experts to learn how we can combine machine learning with medical expertise to create better procedures for patients or for research for medical research. And the picture on the bottom right, that's the picture of the lab that I'm part of as part of my PhD at Warwick University. David, if there are any questions that you see that you think I should answer, just let me know, because I've started missing them. There were so many coming.
No worries. There are a couple of questions. I mean, there's one that I don't know. One says, what are your opinions on binaural beats?
I also don't know what it is. There are a lot of things that I need to look up then.
I know. And do you think this is related to subconscious programming? Again, I'm not sure what subconscious programming is either.
Yeah, I also don't know. We'll have to do another call with the students to figure it
out. Someone is asking. Well, Junden's asking, why did you get into machine learning?
Why did I get into machine learning? So that's a good question, because at the first, my undergraduate was in economics and finance when I started, and my undergraduate was in the United States in North Carolina. I wasn't the best student I was in high school, and a lot of the time I spent swimming because I was part of the national team. And then I just went for undergrad for whatever I thought would be a sensible kind of choice. But then I quickly, as I got into my studying as an undergrad, I quickly was dissatisfied with studying economics, and I wanted to look for more kind of ways to justify why certain law in economics can be used and certain law cannot be used. And that brought me into looking at statistics, and then ultimately wanting to do masters in mathematics and something to do with statistics, where I can actually learn more deeply about how statistics can be used to verify what works in practice, what doesn't work in practice. And that's how I got from mathematics and statistics into machine learning, because machine learning is very much built on statistical foundations. And then I was curious on, okay, how can I have impact on the world with that research? And that's how the opportunity to do a PhD with machine learning in medical imaging came about. And I thought that's an excellent opportunity to work with different medical doctors, learn how they work and how I can be useful for them as a scientist in STEM. And that's how I essentially got into machine learning.
Brilliant. I've got another follow-up question as well that was quite interesting. If you want to have a better understanding, this is from Hassan, if you want to have a better understanding of machine learning under the hood, is it better to study computer science at uni or maths?
Oh, that's an excellent question. So they are not, I would say they're not mutually exclusive. It's not like computer science is in one box and mathematics is in another box, and you can't integrate them together. Especially when you're at university, there are a lot of opportunities when you're studying computer science to go and do some courses in mathematics or statistics. Or when you're in mathematics and statistics, there are usually opportunities to take some courses in computer science. And I highly encourage to do that and try to broaden kind of your experience, learning experience. At least that's what I found while I was at university. Of course, it would depend on a program, but usually universities would be quite up for you to try to experience different things. And if you can justify that you want to do this because I want to learn machine learning. Also, now computer science degrees integrate a lot of mathematics into the course to learn machine learning because it's becoming such a highly demanded skill, machine learning. So that's why computer sciences are also incorporating all those foundations in statistics and mathematics as part of the curriculum so that you can actually learn and be aware of them. And it's important also, once you have some basic knowledge of mathematics, there are a lot of things that you can pick up yourself just by doing things and experiencing things. So hopefully that answers the question.
Amazing, thanks, Jev.
Yeah, should I carry on?
Yeah, great.
Okay, excellent. Yeah, so this is about the communities that I've kind of met as part of my master's and my PhD in medical imaging and machine learning. Actually, the picture on the top middle, it's me and my colleague, Navid. He just graduated with his PhD and is working for a medical imaging company in New York, where they're specifically developing these AI technologies now to be deployed in clinics and help doctors in making diagnoses. But this is a picture where him and I are visiting one of the pathologist doctors to figure out some of the algorithms. So there was a lot of work there. And then from PhD, I'm also moved on to industry, where in London, I work for a company called Cervest. I'm a scientist there, where we work with climate data and try to predict risks from climate change to different organizations, from governments to private companies. And this has been a phenomenal experience for me to work as a researcher, in industry, because you actually learn how do you apply your research, what are the most practical ways to apply your research and have an impact right there, right then, as you're doing research in the company. And besides that, it's again has been an experience of excellent community and people actually having tremendous impact on the way I see the world. So as I was working as part of this company, I learned so much about the ethics of science. What are the ethical ways to do science and what are the impacts of the research that you're doing in the real world? So for example, if we provide amazing predictions of how climate is going to change, and this will have impact on different communities, how do we make sure that there is, we don't have negative impact on these communities by sharing this information with different organizations? I've also learned a lot about climate scientists by meeting different climate scientists. So picture on the left top, we're having a climate scientist from ECMWF, which is the European Center for Meteorology and Weather Forecast, give us a presentation on how we could potentially use machine learning to forecast weather and climate. The picture on the top is our company having a kind of a hangout on the rooftop, all of the different researchers and partners of the company just having a chat. And also on the picture on the bottom, I helped them to formulate the concept of Earth Science AI, where we combine Earth sciences and AI technologies together to be able to do these predictions for quantifying climate risks. And that also had a tremendous impact of my understanding of the world and actually how important the climate change issue is. And learning also about ethics there, I actually became more of involved in activism and actually going to protests and supporting political change that is required. And that is really important for a lot of scientists to understand too, that the science actually has real impact on the ground, and it's important to carry responsibility for what you do. Now, how was my Uni of Warwick experience? It was a good experience, I would say. I arrived there as a master's student. I didn't do my undergrad there. I arrived there as a master's and PhD student. So I can't really speak about undergraduate because I didn't personally experience it. but my sister is actually doing a degree there in mathematics and physics now, and she seems to be quite happy with the experience there. So if anyone would like me to connect you with my sister, I'm happy to do that too. If you want her to answer those questions, I'm happy to do that. Right, so this was my experience at Cervest, where I learned all of these things and learned how to actually use science in practice. STEM is also an impact from that. When you're doing science in industry or even in research, you know that you are having an impact. Some research topics might have slower impact, but some research topics might have faster impact. And specifically AI is actually now the time it takes for your research to have an impact in the real world is very short. So one example is Google. So this is an article from Google blog post. They developed at Google a model called BERT in end of 2018. BERT is a neural network model that understands natural language, the language that any of us speak. And they, after a year that they've developed, they already had it deployed, used as part of Google search engine. And anytime you search something on Google, anytime you use Google for any other purposes, Google is using a neural network that was developed by researchers to understand what is that you search for and then serve you the best possible answers that Google has in their database to answer your search. So researchers are having very, very fast impact now on the world. But that also means that technology, no matter how well designed or how smart your research is, it's only a magnifier of human intent and capacity. So as a researcher, and I'm sure all of you will be future researchers and critical thinkers, you really need to think, okay, I have this awesome research, but what actually is my intent behind here? And you want to think that carefully, that you actually do have the best intent possible, and you think about the possible downsides of your research. So Kentaro Toyama was a researcher at Microsoft, and then he was running a research group in India on having a social impact from research, and he wrote a book called Geek Heresy. It's a really good book. Recommend reading it. So that's how lately it's became very popular for researchers to actually take an active social stance and develop organizations like AI for Social Goods, host workshops, and actually be critical of technology and see, okay, what is the best way that we can use technology to actually make the society better? And it's becoming really relevant now, because if you think about all of the apps that we're using, like Facebook or Netflix, a lot of the technologies underneath those apps that you're using, they're driven by AI. So we need to be really careful as to what is that AI is trying to do when the AI is on those platforms, what impact it's having on the society. So we need to be critical of our own research as a researchers now as well, because we have such fast impact on the world. And
actually a really good. Oh, can I jump in, Jev? Sorry.
Yeah.
I quite like this. There's a couple of questions. One was I think in relation to what we're saying here. Are there any machines that control the mind?
Well, that's a very good question, actually. And you can think of, let's take Facebook or Instagram or Twitter or TikTok, any other social platform that we're using nowadays. The algorithm, the AI algorithm underneath those apps that serves us the content, the information, the new video or the new post that someone made, these apps, these algorithms serve you the post that the AI thinks will have the most impact on you, that this post is the post that you are most likely to interact with, the post that you're most likely to click a like or you're most likely to comment on. So implicitly, that algorithm, by serving you something that you're most likely to have an interaction with, it slowly changes your mind, just slowly gives you different facts, different information. And in the long term, that might have an impact on you. So that's why we need to be really careful with the social media systems that we design now and what algorithms and what these algorithms are optimizing for. So yes, in a sense, there are AI algorithms that are changing minds, I would say.
Brilliant. Oh, and another one, just a follow-up, which is on a similar idea. There's a lot of, I think this has sparked quite a lot of discussion, actually. Do you think AI will threaten key workers and workers in the future?
And by key workers, is it relating to who specifically?
I think maybe we mean the workforce in general.
So that's a really good question, and there's been quite a lot of research on that. And I've mentioned a paper here from Oxford, published at the AI for Social Good conference at Vancouver as well, where they tried to study how many medical professions are likely to be automated. And for example, the situation there is that it's unlikely that a lot of professions are going to be automated. What is more likely is that these tools are going to augment the way medical doctors work. Because at the moment, AI can classify cats and dogs for you. AI can classify tumor or not tumor for you, cancer or not cancer for you. But medicine is way harder than that. Medicine is actually a decision process. Okay, this patient has a cancer. Let's look at what are the features that patient, what are the symptoms that patient has, what are the different genetic tests that show some information about this patient. And given that, me as a medical doctor and knowing all about the medicine, what is the optimal treatment for that patient? So AI can only speed up, in a sense, the diagnosis, give more information to the patient, but the final decision will be made by the doctors. And it's quite a complicated decision tree of decisions that doctors have to go through to make a decision one or another way in regards to a patient. So in a sense, these highly specialized jobs are not going to be automated.
Great, thanks, Jeff. Just another follow-up just from Haresh here. He was mentioning, I think when you were talking about the sort of way that Facebook is using lots of our data, is this related to big data? And do you work with big data, like this term big data in your work?
Yeah, so big data is a kind of very popular term. It's hard to say what is big data, but certainly what Facebook works is big data. Certainly what I have worked with is big data. When you work with pathology medical images, each of the images itself, when it's compressed, it's 2 gigabytes, but when you uncompress it, it can be up to 70 or 100 gigabytes. It's a massive 100,000 by 100,000 pixel images. They're huge, and you're working with thousands of them. So you have to develop algorithms to efficiently process these images. So it is big data, and you're working out the best way how to handle that big data.
Cool, great. Thank you very much. Amazing.
Yep. Excellent questions. Yeah, so AI for social good and being critical of your own research is really important, and it's becoming more and more important nowadays. And we also have to realize that often technology is not the only or right solution to a particular problem that we might have in the society or in industry. But what's the value that STEM brings to you is the ability to think critically and constructively about the problem. And that becomes really important, is something else that you get out of the STEM degree. So that often, if you get a degree, let's say in computer science or mathematics, or you do research in master's or PhD, a lot of people will not necessarily stay in research, but they might also go into consulting or other jobs where that ability to critically think about the problem is still very important and very valuable. And you see quite a few people who come out of research and go into consulting and can use what they've learned in STEM to decompose problem into its simpler parts and think constructively about the problem. That's really important thing that you learn in STEM. And David has sent me some questions about my career. So I thought I picked a few and I thought I would answer. What programming languages I use in my career? So for me, it's been mostly Python, R, and Julia. And I've been using a lot of packages. Packages are essentially a piece of code that has software that has been put together to reuse certain functions or certain methods that have already pre-programmed. So I've been using a lot of PyTorch, which is a package for deep learning, specifically AI. But programming languages themselves are tools, and you should really just focus on the problem and what is the optimal tool for the problem that you're working with. So there are loads of programming languages and loads of different tools that researchers might be using. What is the greatest achievement in regards to computing? So I've worked, as I've said, I've worked with very large medical images, and there are some examples here on the right. You can see that the image itself Can you see my mouse? No, you can't really see my mouse. Oh, here it is.
Yeah.
So this is the medical image. It's huge. You can imagine it's 100,000 by 100,000 pixels or different dimensions. And then the actual information we care about is this little square. And once we zoom in here, what we see here is individual cells in the tissue. So these are lymphocyte cells, all these black dots. And this is what we want to look at to make certain diagnosis about cancer or not cancer. And our algorithms don't just have to process each individual square, they have to split the image into many little squares, millions of them, and then process each individual square and learn to classify them, cancer or not cancer. So what I happen to work with is this machine on the left. It's called DGX2. It's a relatively new supercomputer from NVIDIA, which is powered by graphic processing unit, and anyone who is gaming computer games should know what a GPU is. So this one is packed with 18 top-end GPUs. Each of them have like 40 gigabytes of memory, or 32 actually. And you train these neural networks on these graphic processing units because it's far more efficient to train them on GPUs than on regular CPUs. So doing computation on that machine has been so far the largest computational achievement for me. But what's also important is that a lot of these things are expensive. And if you really want to have a real world impact, once you can put your algorithm that you developed on a phone that everyone can access, that's when you're really having an impact, because then it's suddenly very cheap for everyone to use your algorithm that you've developed. And what are the current limits of the machine learning? And I thought that I kind of will state the contradictory answer to this question. I think the limits of it are currently the speed at which the systems are developed and used in practice. So we don't really think sufficiently about what are going to be the consequences of the systems that we deploy in practice. So this is the recommender systems that we put in Facebook that optimize for user engagement and might kind of create communities that might have such disagreeing opinions between one another. And these communities are created purely driven by algorithms, by algorithm having misspecified what it is optimized for. And researchers really need to think carefully before they deploy AI systems, because they work with big data, they work with everyone's data. What are these systems are actually exploiting? And we should be really careful to not let those systems exploit the worst traits of us, but actually help magnify the best traits of humans. And what extra activities did I do in uni? So big part of my life has been swimming. I was swimming for the national team in Lithuania. I'm originally from Lithuania. I went to 3 European championships in 2009, 2011, then 2012 in Finland, Belgium, and Serbia. And that was how I managed to go to United States and study there, because otherwise I would not be able to afford it. And I managed to get a scholarship for swimming. But while I was at uni, I founded, because I was studying economics and finance, I founded a student managed investment fund and was able to get $40,000 in funding from university trustees to give to students to develop investment strategies. But I quickly learned that I'm not interested in finance because it's very much kind of industry for itself rather than actually kind of having an impact on the world. And that's why I got interested more in climate science and medical imaging, where you actually help people. But the picture in the middle, it's me attending a conference in New York while I was an undergrad to meet different people in finance. And this is a person whose work I was really interested in at that time. He was a quantitative finance person who used machine learning to develop different algorithms for finance. And picture on the right, when I was an undergrad, I was also a swimmer with the university team in the United States, because that's what allowed me to have scholarship there. And this is a picture when it was my final year and I was a captain of the swimming team, and the swimming team did like a surprise for me and sprayed me with these different holiday sprays, kind of celebrating my final competition. And I've also attended a lot of different hackathons and events where people try to hack different things together for a specific question or topic. And this is a picture on the bottom where I'm attending a hackathon, and you can see my laptop there where I'm working with a team trying to develop an algorithm to classify different genetic disease, different given genetic data. And that was also during my undergrad. So that was quite exciting. So loads of different things that I was trying to do during undergrad. As I was saying before, try to maximize different experiences during your undergrad or whenever you have an opportunity, if you have an opportunity, and kind of don't be afraid to reach out to people and say, hey, let's do it. The worst thing can be they will say no to you, but that means that you already tried that and you can move on and offer that to the next person who you think might be interested in it. So yeah, don't be afraid to try opportunities. What platforms did I use to learn machine learning in college or university? So, like as I've mentioned, Andrew Ng has an open free course on machine learning. That's the first link. I learned that during the start of my undergraduate. And the book on the right is a really good book that I used during my master's. It delves deeper into the statistics, and you kind of can quickly figure it out once you have the mathematical basics. And it does a really good job in building the intuition for you on how different things work. And there is also Open Mind organization, which you can involve in any day, as long as you have a computer and the internet, you can start kind of collaborating with them right from the start. You can also join Kaggle, create an account on kaggle.com. And there, what Kaggle does, it hosts different competitions with big data where you yourself can work with that data and try to see how good you can do on classification tasks or any other tasks, or like self-driving car tasks as compared to many other people. And you can see, and you can get feedback straight away and interact there with the community. So again, kind of the biggest advice I can give is always try to find a community and engage with that community, because that's the fastest way to get feedback and learn from people and kind of find the people who you can aspire to be like, essentially, and find role models for yourself. And the bottom book is an open source free book on deep learning. It's a really cool book. It's built by really cool young researchers, where as you go through the book, you learn different topics and intuition, and they straight away give you the programming code. So you can learn programming while learning machine learning. So that's also really cool. And I believe that's my last slide. Yeah, so thank you.
Oh, Jev, thank you so much. That's amazing. Have we got time for just a couple more questions? There's like just a couple questions to.
Yeah, absolutely. Just can
Brilliant.
I just get water? I really would like to get some water. Just
No
give
problem,
me 5
no
seconds.
Problem.
Thank you.
Again, go do that.
Yep.
Go do that. If anyone's got any other questions as well, please do let us know. No problem, Shar.
Alrighty, I'm back.
Hey, no worries, brilliant. Okay, the question from Mohammed Al Islam. I can't answer. There's loads of questions. I can't put them all up. I'm just going to be able to put a couple up. Would a career in software engineering still allow me to work with machine learning? I would say so.
That's a very good question. I recommend looking at the results from OpenAI organization on GPT-3. And what they've shown is actually they trained a language model on different public source code, public programming that has been done by other people. And that machine, that algorithm learned to write programs as you tell it, oh, write me a HTML page in HTML that has a yellow button and letters and says Google on it, and it will generate for you that page, the code that does that page. So I definitely think as you go into software engineering, you will definitely encounter AI, because it's also going to augment the way software engineering is done by using AI, essentially.
Brilliant, yeah. Another one here from Jundin. From what I read related to cybersecurity, it is able to detect threats before they occur and defending against DDoS attacks. How powerful can AI and machine learning be when integrated in other fields, maybe like in terms of cybersecurity?
So I don't know sufficiently enough about cybersecurity, but I can say that from Some of the acquaintances I have that work in cybersecurity, they already use AI to develop, for example, anomalous activity on the system. So you can train machine learning models that essentially are able to classify what looks like as a normal activity and what looks as abnormal activity. And actually, the machine learning model that would do that is the same kind of machine learning model that I used for the work that I did with exoplanets, detected 50 new exoplanets with very similar kind of model. So once you know these models, you essentially can find different domains where you can apply them, from cybersecurity to astronomy to climate science to biology. But what's really important to recognize there, if you're a machine learning expert like me, you have to work closely with people who really understand the domain. So I have to work closely with doctors to be able to ensure that models do a good job there. I have to work with climate scientists to ensure that models do good job in climate science. I would have to work with cybersecurity experts to make sure that models do good job there.
Great, thank you. Two final questions. Any opinions on the future of quantum computers?
Oh, I can't answer really that question. I don't have a background in quantum computing, but I know it's something that everyone is really interested in.
Yeah.
All I know at this point is that they can do very specific computations, and from what I read, they will be specifically used for certain problems, but not generally used. But I might be completely wrong here because I don't have the background in that.
Right, final one. What subjects did you take to do machine learning? I suppose like when you were at school.
Mm-hmm. So at school, I first thought that I was taking actually a lot of chemistry when I was at school. I don't know why. I thought, but I was also taking a lot of physics. I kind of was not sure if I will go into where I will go, but eventually I went to do a degree in economics for my undergraduate. But that's why I was taking simultaneously and physics and chemistry. But that's why also I didn't do well in either of them, because I was taking two at the same time. But that's purely because of the system in Lithuania. You can have either one or another, but you can't have both. And if you do have both, it's just too much. And that's what happened to me. But I would suggest, if you're taking maths and physics, or instead of physics, chemistry, or any of like sciences, you will be prepared to go into these fields. That's what I would say. There is plenty of material now online as well that you can use to kind of brush up and kind of learn and look into what you need to learn.
Brilliant. Okay, like I'm saying, we can't answer all your questions, but thanks so much everybody for being online. This will be available after the session, guys. I think if anyone wants to view the session afterwards, I will post it up. We will be posting it up on some of the Google Classrooms and stuff like that, so you can look at that later. Again, thank you so much to Jev for joining us today. It's been really, really informative and really, really amazing. Thank you so much.
Yeah, thank you so much. It's a really great opportunity for me. And like I've said, if anyone has any questions, like I've shared my details so people can reach out. I'm happy to answer as many questions as there might be. And yeah, like happy to do, very great opportunity, and hope that had positive impact for students as well.
Fantastic. Yes, I think it did. Thank you very much, guys. I'm just going to end that here. So thank you so much, everyone. And thank you, Jev. Amazing. Cheers.
Thank you. Thank you.